and welcome to the video. This is one video in a series of 4 which aims to show students exactly what a grade 9 question looks like in GCSE Maths. There is actually no such thing as a grade 9 topic, as some topics can be tested at grade 5, but then that same topic can also be tested at grade 9. It is actually based on how complex and how challenging a question is. That is what qualifies a question as a true grade 9 question. The simplest way to identify these questions is to look at the very last question in recent GCSE Maths papers. Here are some of those questions. Okay, let's have a go at this grade 9 question based on arithmetic sequences. The question does refer to the sum of the first 48 terms and the sum of the first 36 terms. In the formula booklet, you will be given a formula which will help you work out the sum to n terms of an arithmetic series. That is going to be vitally helpful in this question. This question has been allocated 5 marks. Could you have a go at this grade 9 question? Could you pause the video now, please? Okay, let's have a look at how I've started the question. So this is the formula for the sum to n terms, which is given in the formula booklet, with n being the number of terms, a being the first term in the sequence, and d being the common difference. This is essentially what this sentence tells me. The sum of the first 48 terms equals 4 times, which is why I've included this 4 here, the sum of the first 36 terms. I've inputted my n value into the equation, but of course I don't know the first term or the common difference yet. I've just went ahead and simplified it slightly. So I've divided this by 2 to make it 24, and then I've expanded the bracket. I've divided this by 2 to make it 18, and then I've expanded the bracket, and I still have the 4 outside of these terms, which relates to the fact that it is 4 times the sum of the 36 terms. Now I've went ahead and expanded this bracket, so I've multiplied 36a by 4 and 630d by 4. Then I've just tidied up. I've moved all the like terms together and made this equal to 0. So I've moved all the terms onto the right-hand side of the equal sign. What I'm going to do now is I'm going to look at what the question actually asks me to do, because at this point I can't go any further. There's nothing else I can do with these terms. But if I have a little look at the question and try coming in from a different angle, then maybe I'll be able to use this correctly. So if I want to find the sum of the first 30 terms in the series, again, I've inputted 30 as n, and I've created this bit of algebra here. Now if I go back up to this bit of algebra, these terms, and look what I ended up with down here, 2a plus 29d in the inside of the bracket multiplied by 15. So what I'm going to try and do up here is I'm going to try and factorize, and hopefully I'm going to end up with 2a plus 29d. And that is exactly what happens. When I factorize these terms and remove 48 as a factor, that leaves me with 2a plus 29d, and that's equaling 0 based on this 0 here. So what that tells me is inside the bracket, 2a plus 29d must equal 0 because 48 multiplied by this bracket is 0. So the 2a plus 29d has to be 0. So now I can look at these terms, 2a plus 29d. I've now confirmed that they equal 0. So now if I go back over here and have a little look at these terms in this bit of algebra, I now know that this is 0. So I've just replaced that with 0. I'm left with 15 multiplied by 0. So actually, the sum to the first 30 terms in this series is actually 0. And that is how you answer this 5-mark question. Manipulating the algebra after you've created an equation. Once you get to this point, you can't go any further, but what we can do is factorize, and what you're left with inside the brackets will eventually lead you to understand that 2a plus 29d is 0, which we can then use over here to calculate the sum to the 30th term. Very well done if you would have picked up all 5 marks on that question. This is a 5-mark question which involves the topics of bearings, the cosine rule, and also the sine rule. Gives you a lot of information in the question, and you probably want to start your answer by putting that information into a sketch or a labeled diagram. Could you read the question carefully, pause the video, and have a go at this challenging grade 9 question? Okay, welcome back to the video. Let's have a look at how I have approached this question. The first thing I've done is I've taken the information from the question and drawn it in a labeled diagram. So we are told that y is on a bearing of 280 degrees from x. So there's x. There's my bearing, the inside arrow of 280 degrees takes me along to y. And z is on a bearing of 220 degrees. So here's y, here's my north line, 220 degrees, there's my line, and there is z. I'm also told a couple of distances. I'm told that x to y is 3.5 kilometers and y to z is 6 kilometers. Then I'm asked to work out the bearing of z from x. So I've just joined up z and x to create a triangle, and I've highlighted here the bearing I'm actually trying to find. So this highlighted bearing is what the question is asking me to find. That's everything the question tells me, but there's a few more bits of information I've added to the diagram. For instance, if this bearing is 280, I know that this angle here has to be 80 degrees because of angles around a point. And now we have a case of some complementary angles. So this angle here and this angle here, bearing in mind that both north lines are parallel, have to add up to 180 degrees, which makes this angle 100 degrees. And what that helps me with is if I know this full bearing is 220, and this angle outside of the triangle I've created is 100, that's telling me that the angle inside the triangle must be 120 degrees. And it's this 120 degrees that I need to continue with the calculation, continuing trying to find this bearing. So what I'm actually going to aim for is I'm going to use the cosine rule and the sine rule to find this angle here. And once I know that, I should be able to calculate the bearing which I have been asked for. Okay. So if I look at the information I now know this angle is 120 degrees, and that is enclosed by a length of 6 and a length of 3.5. Because I know an angle in between two lengths, I can use the cosine rule to work out the third length. So I'm going to work out the distance from Z to X, which in this little diagram, I've labeled B and C, just so it corresponds with the common way of writing the cosine rule. Then I've went ahead and substituted in little b, little c, little b, little c, and capital A, which is my angle 120 degrees. Once all that gets put into my calculator and calculated, and of course square rooted, I find that the length of A is 8.32 and so on. So this distance here is 8.32. So that's going to be helpful for my next step, because I needed this line, I needed this distance in order to apply the sine rule to work out the angle that I'm interested in, this angle here. I couldn't jump straight to that angle because I was missing this bit of information. Okay, so if I draw out the question again, and now I've included my 8.32 for this length here. So now I have some information. I have an angle and I know the length opposite it, and I want this angle and I know the length opposite it. So now I can use a section of the sine rule, input capital A and little a, and input capital C, which in this question remains as theta, and little c, which is 6, the length opposite. You may have labeled it slightly different, but I've just went ahead and labeled it the same way I labeled it for the cosine rule. So again, I can use the common version of the sine rule. Now I need to solve this equation for theta to work out this angle, which is this angle here that I highlighted earlier. So I multiply each side by 6. This gets calculated, and then I take the inverse sine of this side, which is going to leave me with theta, the angle. And that tells me that the angle is approximately 38.6. So this angle here, which is this angle here, is approximately 38.6. When I'm saying approximately, it's because I've took it to one decimal place, because I know when I do my subtract in a second, I need to give my answer correct to one decimal place. Okay, so now I know this angle, 38.6, but that is not my final answer, because what I actually want is the bearing from the north line of X to Z. So if I know the bearing from X to Y is all the way around here, I can use that bearing of 280, subtract this value of 38.6, and that's going to leave me with the bearing that I require. So all I need to do now is go ahead and do a subtract. The bearing of Z from X, which is what the question's asking me to find, is 241.4 rounded to one decimal place. And how I calculated that was I used the bearing of Y from X and subtracted the angle that we just calculated using the cosine rule followed by the sine rule. And there you go. There is my completed answer, and I would have picked up all 5 marks for showing my full correct working out. Very well done if you would have been able to achieve all 5 marks on that question. Thank you for watching, and remember, practicing past paper questions is easily the best way to be successful in GCSE Maths.